points. I know you guys missed having that in the videos. Here's one. We had one just like this on the quiz. The first step is to use the law with radicals in it. I haven't numbered them because some of you asked, do I have to order them the way you did? No, the whole point is just to know them so that you can use them. So use the law with the radicals, which says that anything with a radical is going to be 1/2. If it's a cube root, you would use the one with the p's and the q's. And step 2 is to use the law, this one, that brings the powers inside. So if you have a power on the outside, everything inside gets multiplied. I'm going to have to pause because people are taking notes. By the way, some of you were asking me about that Calc 1. They took it away from me. Yeah, it's a 4-credit class, so professors want that.
So what happened?
I don't have it, but I can tell you who teaches it once they... Actually, I can tell you now who's going to teach it.
Who's the best?
I can't tell you that. Not while I'm recording. You know, there is no... Honestly, there is no best. It's like who's compatible with whose personality. Right? So you'd have to look at who's teaching it and the person's personality. Because some people like a lot of structure, and they would like a professor that's really structured. Some people like it to be really laid back, so they'd like a professor who's really laid back. So depends on the person. Okay, everybody got this? You can just refer to the law off your notes and say this is law number this. You don't have to rewrite the whole thing, unless you want to. I think I might have copied and pasted. Okay. So if you apply that law, see what I did is I brought the 1/2 inside with the negative 14, so it became negative 7. 1/2 with negative 16 became a negative 8. 1/2 times 2 becomes a 1, and 1/2 times negative 14 becomes negative 7. So if you're taking notes, just put equals next to what you just wrote so that you can see that this is the next step. So I put some notes on there. You don't have to add it to yours, but just in case you get, if you forget like where these things came from, that's the steps that I just announced verbally. Next step is to apply the rule that says b to the m divided by b to the n is b to the m minus n. That's step 3. So here you have a to the minus 7 and a to the 1. So it's minus 7 minus 1. And b to the minus 8, there's nothing more there, and that stays. The only two that have the same bases are these two, the a's. Yeah, then you have to, I would always use your calculator. I mean, because it's not, first of all, adding fractions, if you had to do it, you could, right? You just sit down and get a common denominator. But usually when the problems become longer, you want to just get the answer quickly. And make sure you didn't make a mistake because they're multi-step, so you want to make sure that you got the computation done correctly. What do you have, a TI 86? It'll do it. So if you have whatever calculator you have, just look it up on Google and say, how do I add fractions on it? And it will somebody will have screenshots one by one explaining how to use Google. Remember my policy of the cell phones. Crotch smiling things happening. So in this case, the m, just to give you some, in case you're looking at the notes later on, that m would be minus 7 and the n would be 1, and I'm putting it into that formula. I put these things in here because I've been told by students many times that they go home and they understood clear as a bell in front of me, and they went home and they couldn't do the problem themselves. And so we'd go back and forth, and I figured out that, okay, it's these little things, like they're sitting there scratching their heads going, where did that -8 come from? That's why I put those in there. I know they're annoying to see and hear because it's probably clear. And so I'm down to this step now. And now the way Webassign wants you to put things in, and I know this because on my Webassign I have the answer, is it doesn't want negative exponents. So if you want to change them, I don't know if it'll still work if you input it in with the negative exponents, but it might actually. Did anybody try that? Put it in straight in? It doesn't? That's annoying. So I guess it doesn't, but it might be a good exercise for us to move those negative exponents downstairs or upstairs. So if it's negative, it just moves it to the other. If it's upstairs, it goes downstairs. If it goes downstairs, it goes upstairs. So that's what it is. So if you have b to the -m, it goes downstairs. If it's 1 over b to the -m, it goes upstairs. So this is one of the things that confuses calculus students a lot. They get, because they have lots of negative exponents to work with, and they think it has something to do with the number itself being negative. No, the negative in the exponents just says move downstairs or move upstairs. That's all it means. Kelsey?
Do you want us on quizzes to do that?
Yeah, I'll tell you, so you can just look at the rubric and make sure.
Okay. So it becomes a positive, right?
Yes. Good?
Why do we use a bracket? Oh, because we're trying to get to lower radicals.
Say it again?
Why do we
Yeah, that's the first step. You can't do it. I mean, there's other steps to this. When I look at this, I think I have 2 goals in mind. Number 1, get the problem done as quickly as possible. Number 2, get it right. Right? So to me, optimizing it would be to get those radicals as fractional powers. Some teachers like to take that radical and put the whole thing over. But if the problem changes slightly, and you have a square root on top and a cube root on the bottom, change them to fractional powers. You see how quickly I got rid of everything with the fractional powers? Fractional powers are a good thing.
So you only made it positive for Webassign, but we don't have to make
No, I'll tell you if you have to make it positive, but it's a good thing to do because, again, if you're taking calculus, it's an important skill to have. Yeah. Still writing? We're done. Number 7's messy. Put your seatbelt on. This is going to be a longer one, okay? This is what we refer to in, the kids in calculus refer to as taking the derivative the long way. These are the steps. You know, the rubric does a very nice thing for me. It makes me be very unbiased when I'm grading. I have to, right? Because I'm looking at that rubric saying, I really, really, really like Carolyn, but I can't, deviate from the rubric. So that's what it does. What's really important to understand is it can go the other way too. Unfortunately, sometimes I felt like that in classes that, oh, this professor has judged me already. They think I'm dumb. And in calculus, these are the first problems you get. And very quickly, I think some professors make a determination of whether you have the skills to be there or not, whether you can do these problems. So all of you who are taking calculus, because you're coming out of my class, have to smoke on these things. Make sure you kill these things, knock them out. So I'm going to ask you a few of these to make sure that you know them. So you have to do good on it. You're carrying my name with you. So here's the steps. That's the f of x. Do these slow. These are totally about bookkeeping. First, you find f of x plus h. How do you do that? Wherever the x was, you replace it with x plus h. That's what f of x plus h is, right? It's like a machine. The input, whatever, if it's f at 2, you put 2 in for all the x's. If it's f of x plus h, you put x plus h in for all the x's. From that ugly beast, you subtract f of x. And I say ugly beast is about to get a lot uglier after this. So that's where we're at. On your notes, you can continue to deface. You don't have to rewrite it. You can deface the next one. The reason I'm doing it this way so you can see where each thing came from. And for me, I have a copy paste. So I can now take a lasso around the piece and copy and paste it. It's nice. It's the only nice thing about it. Huh?
Why do we always have to subtract?
That's this is called a difference quotient. What you're I'll show you on a piece of paper on the board what this is for, because it's really cool actually. So I copied that previous thing on the top, so if you're still copying it down, that's this. Now you take that monster that's up there and you divide it by h, like so. So far so good? Now comes the bear. They want you to rationalize the numerator. What this means is you take whatever was on the numerator and you multiply what's called, it sounds like a dirty word, the conjugate. So you take whatever's on top. If it was a minus in between the two, the conjugate will have a plus. If it's a plus between the two, the conjugate will have a minus. Sign swap. And I didn't write it down there because it does sound like a dirty word, but it's not. Right? I mean, if you walked out of class today and they said, what did you do in pre-calc today? I conjugated. Sounds like a bad thing. You would think with you guys being young, you'd laugh at things like that. My seniors laugh at somebody's name named Lipschitz. If I say Lipschitz, everybody starts laughing. You're about to be high school teachers, and you're laughing because I said Lipschitz. It's somebody's name. Okay, so that conjugate, you don't have to rewrite everything. You can go back to this expression at the top and right next to it, multiply top and bottom by this. Which seems like it's gotten a lot worse. But in a second, you're going to see what they're up to. So top and bottom of that monstrous beast that you had in the previous section, you multiply by the conjugate. And it looks bad. If I multiply by something with top and bottom the same, what have I multiplied by? Just 1, right? And 1 doesn't change anything. So I've not changed the fraction at all. So one of the first things that I tell calc students is if you're doing algebra and your expression looks worse and worse at every step, you might be doing something wrong. And then I get to this kind of problem and they say, well, Dr. T, you told us that at every step it's supposed to look better and better, and this looks worse and worse at every step. And I say this is the exception. So here I need a little insight. You know this formula, the one they beat down at Math 100 in the Red House Learning Center, difference of squares over and over and over again, right? Well, up at the top you see a nasty A and a nasty B and a nasty A and a nasty B. I highlighted the A's for you so you can see it. That whole expression there is the A here. See, they're the same A's on both sides. And I'm really taking A minus B and multiplying by A plus B. They're just ugly looking expressions, but they're still yucky minus yucky times yucky minus, it's still just a blob, right? So I highlight it so you can see what I'm doing. And I also put it with arrows at the top so you can see what it is. The A is the first one, the B is the second one, the A, let me go with the mouse so you can see. So here's my A minus B times A plus B. Well, that's A squared minus b squared according to the difference of squares formula. Usually in Math 100, you're supposed to go the other way around. You're given a squared minus b squared, and you're supposed to factor it like this. Here, you're going from this direction, and you're going to replace it with this. Why would that be helpful? What happens to a square root when you square it? Goes away, right? That's why you want to do that. So I rewrote it here because it's tricky. Right? I just rewrote it so you can see that's the a and that's the b. So what's a squared? Right, just remove the hat. All right, take off the hat. The very first semester I taught at a real job, someone came to observe me and they didn't like that I didn't use the formal words for everything. Good thing I didn't use the word hat. It looks like a hat. The radical. Okay, you can't do that, but I just did. See, now I replaced the top, which was a minus b times a plus b, as a squared minus b squared. Keep going down in your notes. You know what a squared is? This is a squared. This is b squared. Okay? A minus, bottom stays, just stays as a big mess. You can't do anything with it. Just the top change.
Oh, basically you just got rid of the
Right. Do you know how many times I've taught this class and done no work in between? And I went from here to here. You have two reactions. One is dead silence. Sometimes I have a class, entire class that's just like, and sometimes I have protests. What? What? So now I put all the steps in. And all my past pre-calc students are applauding. Finally, you put in the steps.
But you said the circle stuff is like the hardest one. You should have learned this first.
You know what? It's messier. It depends on what your passion is. If it's bookkeeping, this is not so bad, right? If it's seeing shapes, if it's trig, that stuff is worse. It depends on what it is. But towards the very last thing we're doing in this class is lines. Y equals mx plus b. Yeah, that's the easiest stuff, right? Because you've seen it the longest. So I'm going to simplify this out. What I did from here to here is I just took off the parentheses. When you take off the parentheses, the signs change. So I got minus 3x and a minus 3. And don't worry about copying because I think I'll explain this. Oh, where did this piece come from? Well, that's FOIL. When you take x plus h and square it out, side by side, you get x squared plus 2xh plus h squared. So that's where this term came from. What? X plus h squared. See the red? Because.
Oh, yeah.
We learned it like this in school. I always liked this. Some people learn it as formulas, but I had a teacher that said when you have a plus b squared, because you have to do it so much. So if you had to FOIL every time, you'd have to either memorize a formula or just be able to FOIL really fast. He just said square this times that double, square that. Square this times that double, square that. Square this times that double is the middle term, square that is the last term. And then he'd make you say it really fast. Square this times that double, square that. And if you can beat him at saying it, get you a dilly bar from where's that place? Dairy Queen. The only place to eat in Glendive, Montana.
At the end there, in the numerator, does it say 3x squared minus
probably should have put a little indication here that signs have switched.
Why? Yeah. why?
Because whenever you have a minus in front of a parenthesis, when you take the parenthesis
Oh,
out,
right.
Yeah.
Why did we switch this like the first?
because there's no minus sign in front of it.
Oh, so it just becomes.
No, I mean, like, I understand why the first one being negative, like negative 3x squared.
It's
and then-
in front of, it's minus 1 times this, minus 1 times this.
Oh, so it's like for.
Yeah, it is exactly that. It's distributive law. Right, exactly.
My question is, why do we first like fourth and why keep this time as well? The first part will be because it's the whole thing started like subtract, you have to subtract anyway.
Right.
So I did it.
So this is a really important question, and when I teach Calc 1 and someone's doing this without changing the signs, I'm wondering who their pre-calc teacher is. So let's get this resolved now. Whenever you have a fraction and you put together the numerators, always remember that that second piece has a parenthesis around it. And that is that entire thing that you're subtracting.
Oh, I see,
Right?
I see it, I see it.
You have to put, that's like the biggest mistake I see in Calc 1 at the beginning. Some people get on board halfway through, and some people never put their parentheses up, no matter what you tell them. You beg them. You say tattoo it. Nothing. They don't put it on. And you know, when they have long calculations and you don't have your parentheses up at the beginning, everything's wrong after it.
So is that problem right there, the white part, the X will be like the B with the A over here, and then the H, the B will be like the H.
Yes, correct.
Okay.
Yes, yes. And if you're looking at this on the video, you can just this is the explanation right here. It's messy because I had the somehow my pen wasn't writing well there, but you can see that it says because. It looks like something scary, right? Because it looks something on Halloween. I wrote it in blood. Okay, so I just copied and pasted the yellow from the previous so you can see the thread of the story continuing and what a story it is. Story, right? You even have blood in it on the previous slide. So that's where we're at now. And now I can start, now I brought the 3 in by distributive law. And now is the fun part. You see some stuff drops out from the top. And this is another thing, if you forgot to put the parentheses on, the stuff doesn't drop out. So then it's true that at every step it looks worse and worse and worse. And that's where I'm at, once those things drop out. And I've got one more step. One more. I copied it. If you're at the last line.
Okay, so we did 3 times x. Okay, 3 times x squared.
Oh, did I forget a 3?
Squared.
I forgot a 3, right?
Yeah.
Right, let's put it in there. That actually should tell you something. If I'm writing this, and I'm always teaching the class, and I ended up making a mistake, even with all that bookkeeping, think how many mistakes people make without the bookkeeping. Ugh, don't do that. So there's my little 3. Okay. So next step, I just copied the peach-looking formula from the last slide up at the top. And next step is to factor out the h. And then you cancel. See, the h is canceled from the bottom. And that's it. In calculus, you'll have one more step, and that's to take h and let it be 0. That's calculus. You just let h be 0. All the rest of it was pre-calculus. Do not do this one fast. Don't do it fast. Like, what are you trying to prove if you do it fast? Just like my sister asked her, why are you doing it fast? You're getting them wrong. Don't do them fast. She never listened to me. But it's harder to talk to your own family members.
You brought the h up, so that's the answer.
All I did is I canceled them, right? If I factor the h on the top out, then there's an h on the bottom and an h on the top. So they cancel. Are you allowed to cancel these h's? No, never do that. You're not allowed to cancel across a plus sign. It has to be multiplication. So that's why I factored first. You felt like canceling the h's? Did you? Did you feel like canceling those h's? Good.
What happened to the square? So we wouldn't do anything else with the bottom.
The h, it's a distributive law. Backwards distributive law. Multiply the h's back. So you get 6xh if you multiply the h back. Here you get h squared. I factored the h out. You won't get a square anymore. H times h is h squared.
If that's the final answer, we're not going to set it equal to like the 1 minute focus each.
No. But that's calculus. Just one more step to the minute goes. But it's like getting there is the hard part.
But you need to look at h.
Yeah, it's supposed to be like a square up there still, because I was thinking it was 6 times x. But then, so you brought the h outside?
Right.
One of the h's, we have the one h.
But
Oh,
it
you
was
factored out an
three
h.
h's up
But
there.
no, you factored out an
I factored in the
h
h.
squared, but instead of being a square, it's like 1.
Like you know what? You're used to multiplying, not dividing, not factoring. So multiply h times this gives you the previous 6xh. H times this gives you the 3h squared.
Oh, so you just did it backwards.
Backward, that is what factoring is. It's backward multiplying. Question? Stretching?